Hello, everybody. I wanted to give y'all a little rundown on z-scores. It seems like there is some confusion on this homework assignment, so I'm going to give you kind of a step-by-step tutorial here, and anybody that wants to redo theirs and turn it in can get full credit. But I wanted to give y'all a little idea of what's going on here. First of all, what is the z-score formula? So z equals x minus the mean divided by standard deviation. So there's a couple things you probably notice here. You need, in any sample, you would need the mean, which again is the average. You also need the standard deviation. So what's the formula for standard deviation? Standard deviation is equal to the square root of this scary looking e thing, just means the sum of x minus x bar, which also means the mean, squared, divided by n, which is the total number in the sample. And lastly, of course, you need the mean. This, of course, is just the average, but if you wanted a fancier looking formula, it's the sum of x divided by n. Again, x bar is also the mean. So if we take that first part of your homework as an example, we have a couple numbers here. We have 9, 5.5, 4, 8, and 6.5. And it's asking us to find the z-score and also the probability, p. So our first step is to find out what the mean of this is. And of course we can just add these up. 9 plus 5.5 plus 4 plus 8 plus 6.5. Divide that by 5 and we get a mean of 6.6. Now the next step is to find the standard deviation. Again, we have our formula up here. How do we actually go about doing this? So now we're just sort of plugging in numbers. X is interchangeable for any of these numbers. In fact, you'll need all those numbers since you need the sum. So I like to sort of take the standard deviation apart. Let's just focus on this top part right here, not worry about the rest of the formula right now. So what we're going to do is we are going to take, we'll start with 9 and plug that in. So we're just doing in these parentheses right here. So x would be 9, the mean would be 6.6, and that's going to be squared. 9 minus 6 squared equals 5.76. Next one, 5.5. And again, we're just plugging it in. So really, we're just going to do the same thing all the way down. 4 minus 6.6 squared, 8 minus 6.6 squared, and 6.5 minus 6.6 squared. 5.5 minus 6.6 squared gives us 1.21, 6.76, 1.96, and 0.01. Now the sum of these is just we're just going to add them together. So we get 15.7. So now we have this part of the equation done right here. And we can go ahead and plug that in. So if we continue on, standard deviation is the square root of, now, 15.7, takes care of that top part, divided by n. N, of course, is any number of actual occurrences of something in a sample. So if these were test scores, or whatever they were, 9, 5.5, 4, 8, and 6.5, you can think of them as individual pieces to the puzzle, pieces to the entire population. And in this case, we have 1, 2, 3, 4, 5. Sorry, n is 5. We just do 15.57 divided by 5. Next step, go ahead and do that. That's going to give us 3.14 which if you remember from last time, this is our variance right here, since variance is just standard deviation squared. So we take the square root of 3.14. That's going to give us 1.77. That's our standard deviation. So now we have our standard deviation, we have our mean. Let's do the z-score. So I'm going to do the first z-score. I'm going to let y'all do the rest of the z-scores and turn it in with your homework. So the first one we have is 9. So let's plug it in. Z equals 9 minus the mean, again, 6.6, divided by standard deviation, 1.77. And then what we come up with is a z-score of 1.35. In the next video, I'll show you how to find the probability. That's found in the back of your book in the tables. And basically what you do is you just find this z-score, and it writes it there. There's no equation, no formula. It's an actual table that you just follow. But I'll follow this up with another video and give you all an idea. I wanted to give you all a rundown to show you how to calculate the z-score. It's not as complicated as it seems. It's actually quite simple once you start breaking it apart into different parts. For the next table, the one on batting averages, you're going to do the same exact thing. The only difference is you calculate the percentile a little bit differently from the probability. I'll also go into that in the next video.